Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the questions in the question bank of Module 5. The topic is vector integration. In that, I am going to discuss the Part A problems, and this is the first video. So first go to the problems. Verify Gauss divergence theorem for f bar is equal to x square I bar plus y square j bar plus z square k bar taken over the cube bounded by x is equal to 0, x is equal to a. If it is cube, then it must be y is equal to 0 to a, z is equal to 0 to c. So it may not be cube. Bounded by x0 is to x is equal to a, y is equal to 0 to y is equal to b, z is equal to 0 to z is equal to c. So we know that by Gauss divergence theorem, what you know that double integral f bar dot n cap ds over the surface S is equal to triple integral div f bar dv. That is the statement of the theorem. The Gauss divergence theorem is the relation between the surface and volume integrals. So here, given f bar, what is given f bar? The vector point function given x bar, f bar is x square I bar plus y square j bar plus z square k bar. Then div f bar, I have to prove this theorem and call this is equation number 1. And div f bar means this is a del dot f bar. That is, del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with f bar. So what is I bar dot I bar 1? F bar is this is I bar dot I bar 1 dou by dou x of x square. That is the first term. Dou by dou x of x square plus j bar dot j bar 1, that is dou by dou y of y square plus k bar dot k bar 1, that is dou by dou z of z square. This is equal to dou by dou x of x square, that is 2x, dou by dou y of y square 2y, dou by dou z of z square is 2z. So this is 2 into x plus y plus z. This is div f bar only. Now, on considering right hand side part, RHS is equal to integral div f bar dv over the volume V. That is integral, the div f bar is 2 into x plus y plus z into dx into dy into dz, where x varies from 0 to a and y 0 to b and z is equal to 0 to c. So as per the limits given in the problem, x 0 to a, y 0 to b and z is equal to 0 to c. So on integrating the function 2 into, integrating first with respect to x square by 2 xy plus zx between 0 and a, and the limits are integral 0 to b and here integral 0 to c with respect to dy and dz. Integration with respect to x is over. The value is 2 constant, x square by 2 yx plus zx. Now on substituting the limits, integral 0 to c, integral 0 to b, a square by 2 plus a into y. Instead of x I am substituting a, and this is az, and lower limit all are 0 of dy into dz. Now on integrating with respect to y, a square by 2y plus ay square by 2 plus a into zy between the limits 0 and b of dz. This is 2 into integral 0 to c a square by 2 into b, a by 2 into b square plus ab into z, and all lower limits are zeros of dz. So I am doing the successive because all the limits are constant limits. I am doing integration first with respect to x, y, z. So you can do integration in any order because all the limits are constant limits. But here I am doing with respect to x first, then y, then z. So now 2 into, now I am integrating with respect to z finally, a square b by 2z plus a by 2 b square into z plus ab into z square by 2. The limits are 0 to c, the final limits. So I am substituting upper limit a square bc by 2 plus ab square c by 2 plus abc square by 2. Lower limit all are zeros. So what 2 also cancel, I can take out abc common, then you will get a plus b plus c. 2 also gets cancelled in all the terms. ABC I am taking outside, ABC into a plus b, this is called equation number 2. Therefore, div f bar dv is equal to ABC into a plus b plus c, this is called the equation number 2. I have calculated the left hand side part and the value found that ABC into a plus b plus c. Now to verify the divergence theorem, I need to calculate the left hand side part also. What is the left hand side part? Now consider what is the left hand side? Integral f bar dot n bar ds over the surface S. Here the region of integration is the rectangular parallelepiped. X varies from 0 to a and y varies from 0 to b and z varies x. This is a comma 0 comma 0. This is 0 comma b comma 0. This is 0 comma 0 comma c. So here there are several surfaces, 1 and this is 2 parallel surface and 3 and this is 4 and back side 1, 5 and front side 1. There are 6 surfaces. So integral over f bar dot n cap into ds will be integral over the first surface plus second surface plus third surface plus S4 plus integral over S5 plus integral over S6. So now I calculate, this is z-axis, this is x-axis and this is y-axis. You know how to calculate the surface integral, just I will explain here. Now take the surface, this is O and let it be C and this is capital A, this is capital B. A, O, B, O, A, O, C and C, I can write this as C, D, E, F. I am considering the surface. Now consider the surface. What is the surface? C, D, E, F. C, D, E, F. What is the outward normal vector here? The outward normal vector is parallel to z-axis. So z n bar, outward normal vector n bar is equal to k bar. The outward normal vector is k bar. And this is the projection of this plane or this surface CDEF will be on xy plane. And where here x varies from 0 to a and y varies from 0 to b. So therefore integral over S1 f bar dot n bar ds is equal to, the formula will be f bar dot n cap. What is f bar? First I will write f bar. The f bar is equal to x square I bar. Here I am writing f bar is equal to x square I bar plus y square j bar plus z square k bar. Then f bar dot n bar. F bar dot n bar is only z square term will be there because n bar is equal to k bar. ds, because we are considering the projection on xy plane, this is dx into dy by magnitude of n bar dot k bar. Here the limits are x varies from 0 to a and y varies from 0 to b. Already we have seen in evaluation of double integrals as well as in evaluating of surface integrals, and in the theorems also we have seen several problems. Just I am considering the surface S1, let it be surface S1, the surface is CDEF. The projection of this plane will be on XY plane, so the limits will be x and y only. Now the denominator also, this is also 1 because n bar is k bar dot k bar 1. Now what is the value? Z square constant, x 0 to a and y 0 to b, first integration with respect to x, then y. Because these are the constant limits, we can go for in any order. So that is z square into, on doing integration first with respect to x, you'll get x between 0 and a of dy. So that is z square into a also there, a minus 0, integral 0 to b dy, or z square into a into y between 0 and b, that is a b, sorry, this is z square f bar dot n cap is k bar, so this is double integral z square dx dy by n cap dot k bar. Am I right? This is right. N bar is k bar. Outward normal vector is in the direction of z axis, so it is k bar. So z square and this is a dx into dy. But what is z square here? So this is z is equal to a c plane. This is z is equal to c plane. We have to substitute, or you can substitute finally also z square into what we will get, dx first integration. Already we have seen here. Finally also you can substitute 0 to b, 0 to a, z square, and this is first integration with respect to dx then dy. So z square into, on integrating with respect to x first, you will get dx x 0 to a dy. That is z square into a into, and this is b, z square ab. But z is equal to, this is the plane z is equal to c plane. This is the plane z is equal to c, because the plane is passing through 0 comma c. So this is a b c square. That is the first value. Z is equal to c because here z is equal to c. Right. Now to evaluate the surface integral along this OA some KB, OA KB. Now I want to calculate integral over S2 f bar dot n bar into ds. So for the surface S2, means it is OA KB. The outward normal vector will be in the negative direction of z. So n bar is equal to minus k bar. N bar is equal to minus k bar. And what is this xy plane equation? Means this is z is equal to 0. So what you will get, double integral z square dx dy by n bar dot k bar. The limits values are x 0 to a and y 0 to b. Because z is equal to 0, the entire integral is equal to 0. This is the second value. The surface integral along OAKB is equal to 0. The surface integral along CDEF is equal to AB square. So finally you have to add all the 6 evaluation surface values. Now similarly, we consider the surface EDAK. Now consider the surface integral over S3 f bar dot n bar into ds. So what is the surface? This is S3 I am assuming. S3 means the outward normal vector n bar is equal to I bar. The outward normal vector will be in the positive direction of x. Positive direction of x means the value of n bar is equal to I bar, and this value will become double integral f bar dot I bar. You will get only x square. The function will be x square, and here this is d, it is in the direction of, it is parallel to zy plane. So what it will be, dy into dz by magnitude of n bar dot I bar. So because n bar is equal to I bar, this value is x square dy dz, and the denominator value that is equal to 1. Here y varies from, for this plane. For this plane, y varies from 0 to b. This is y. And z varies from 0 to c. Y 0 to b and z is varies from 0 to c. And what is the value of x here? X is equal to a. What is the equation of this plane? X is equal to a because it is a plane from this origin at a distance a from the origin. That means x is equal to a. So what you will get is, I will write this as here. Here I will write. What value you get here? X is equal to a means double integral a square dy into dz y0 to b z0 to c. So on writing this, integral 0 to c, integral 0 to b, the value is x is equal to a square dy into dz. So the value a square, on integrating first with respect to, this is y limit, integral dy y0 to b of dz. That is equal to a square b minus 0. The b is, right, I'm writing outside, integral 0 to c dz. So integral dz is z between 0 and c, that is a square into b into c, that is another value, a square into b into c. Similarly, I can say that for the surface OCFB, for the surface OCFB, let it be the surface S4. Now under the surface, this value of the plane is x is equal to 0 because it is in y plane. So the entire value is equal to 0. So for the, now the double integral f bar dot n bar ds over the surface S4 is equal to integral x square dy dz over S4. But because x is 0, dy dz, the entire value is equal to 0. So 4 surfaces over. This is over, and this also we have calculated, and this also we have seen that value is obtained some value. Now this is 0. Now similarly, you calculate this one over. Next, what is the remaining? This means what? This is, this I can write EFBK. Now EFBK. Now the surface S5, that is EFBK. Just I will search it whether it is right or not. EFBK. EFBK. This surface. The outward normal vector is in the positive y-axis. So n bar is equal to j bar here. The outward normal vector is n bar is equal to j bar. And the surface equation, that x is equal to, this is the equation of the plane. This equation of the plane is y is equal to b because it is a b distance from the origin. So this is y is equal to b. And y is equal to b. Therefore, integral over S5 f bar dot n bar dx is equal to integral f bar dot n bar. What is f bar? X square I bar plus y square j bar plus z square k bar in dot product with j bar. So this is only y square double integral. So the limits are here. The limits are here only for y and x limit. This is y limit. This is y limit. Not that. This is the z limit. This is z limit, and this limit is z limit, and this limit is x limit. So dz into dx, n cap, and this is j bar f bar dot n cap into j bar. F bar dot n cap is y square, and this is a dz into dx by magnitude of n bar dot j bar. That is the evaluation over the surface S5. That is double integral. But here y is equal to b. The equation of this y is equal to b. So b square dx into dz. The denominator will be 1. So what is the integration? X 0 to a and z 0 to c. So b square x 0 to a dz between 0 and c. So what is the value? 0 to c, ab square. ab square with respect to dz. That is ab square into c, and this is the fifth value of the surface integral evaluation. And the last one is surface integral S6. What is S6? S6 will be, this is the surface. S6 will be the parallel plane to this plane. this surface equation is y is equal to 0, so that the entire term will be 0. y0 means y square 0. 0 means the entire term 0. The surface S6 integral f bar dot n cap ds is equal to 0. So what we will get on adding all these 6 values, what are the values? So first we get ABC square. Now I am adding all the values here. This value is ABC square, that is the first value. Second value 0. And what is the third value? Third value we obtain as A square BC. Third value A square BC plus 0 and plus fifth value AB square C. AB square C and last value 0. So in adding all these three, you can take out ABC. The common term is A plus B plus C. This is the equation number 3. It is integral f bar dot n cap into ds. Now on observing the equations 3 and 2. What is equation 2? ABC into A plus B plus C. What is equation number 3? What is equation number 3? I will show it. Equation number 3 is ABC into A plus B plus C. That means what? The left hand side term and right hand side term both are same. The left hand side term, this is ABC into A plus B plus C. And this also, we have reached that ABC into A plus B plus C. That means what? Left hand side value and right hand side value equal. That means what? The Gauss divergence theorem. Therefore, Gauss divergence theorem verified. So here you need to have a knowledge on evaluation of double integral and evaluation of triple integral. If both are known things, then the solving is just by application of the Gauss divergence theorem. You can show that LHS is equal to RHS. So next I will do one simple problem. Thereafter I will conclude my lesson. This I will solve. In the next video I will solve the remaining problems, because all are lengthy problems. So we have to evaluate in one question. We have to do the surface integral evaluation, volume integral and line integral sometimes maybe. So it is a lengthy problem. So find the work done. What is the work done formula? The work done is nothing but integral f bar dot dr bar along the particle from A to B. So to move a particle from point A 0, 0, 0 to B point 2, 1, 3, the work done is integral f bar dot dr bar. So given f bar, this is f bar. What is dr bar? Dr bar means dxi bar plus dyj bar plus dzk bar. Then f bar dot dr bar. F bar dot dr bar is 3x square I bar plus 2xz minus y into j bar plus zk bar dot product with dxi bar plus dyj bar plus dzk bar. So on making dot product, what you will get? 3x square dx plus 2xz minus y dy plus z into dz, the product. So what we have to evaluate is by work done 3x square dx plus 2xz minus y of dy plus z dz from the point A 0, 0, 0 to point B 2, 1, 3. Now we have to find the equation of AB. The equation or OE or AB, equation of AB is equal to, AB is x minus 0 by 2 is equal to y minus 0 by 1 is equal to z minus 0 by 3 is equal to t. I want to write all the terms in terms of single variable. So x is to be replaced by 2t, x by 2t, t, x is equal to t. So y by 1 is equal to t, that is y is equal to t. And z by 3t, that is z is equal to 3t. So here t varies from 0 to 1. I am changing all the terms x, y, z in terms of t and the limits also from single limits. Now it is a t0 to 1. T limits 0 to 1. When t0, x0. When x0, t0. When x is equal to 2, t is equal to 1. Am I right? When y is equal to 0, t0. When y is equal to 1, t is equal to 1. Right? So in that way I am transferring all the values. X is equal to 2t. 3x square. 3 means x square means 4t square into dx. dx means 2 dt. That is the first term. So just you see here 3 into x means 2t whole square, 4t square into dx 2 dt. Next 2xz, 2 into x into z, 6t square. 3 to 6t square into 2, that is 12t square. xz means 2 into 3, 6t square into 2, 12t square minus what is y? T. And what is dy? That is dt. Next, last term, z, 3t. And what is dz? dz is equal to 3 dt. 3 into dt. So all the limits varies from 0 to 1. So this is integral t limits 0 to 1. What is the first value? 3 fourths 12. 12 twos are 24. 24 t square dt first term. Next 12 t square minus t. 12 t square minus t. dt is the common term plus 3t into 3t. 3t into 3, 90 plus 90 of dt. So almost going to finish. It is 0 to 1. 24 plus 12. 36 t square. 90 minus t, that is 8t of dt. So the integration 36 t cube by 3 plus 8 into t dt, t square by 2 between 0 and 1. So what is the value? 2 4s are 8, 3 1s, 3 2s. So 12t cube plus 4t square between 0 and 1. So on substituting the upper limit, 12 into 1 plus 4 into 1, that is equal to 12 plus 4, that is equal to 16 is the required solution for the work done by the force. So in this way we can calculate the line integrals because you have to write the line equation. It is going along the 0 0 0 along to straight line, already has given along straight line. So 0 0 2 2 1 3, the straight line will be like this. All the equations will change in the terms of t, and limits also changes from xyz to t single variable, and on integrating you will get the value is equal to 16. So with the few problems I conclude my session. So in the next video I will do the remaining problems, and here the reference is the question bank of the course Differential Equations in Vector Calculus, and it is the regulations of BT 23 published by IARE. And thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.